And SQS is a point-to-point queuing system that, again, if you've picked this up, the pattern here is zero administration. This thing's just always running. So we drop things on queues, and then we have things listening on the other end. And then last but not least, it's extremely cheap. If you can't see that, it's about 1 cent for every 10,000 messages. We handle about 3 million messages a month, and that's like something like $18. I mean, it's extremely affordable. So a big picture of our architecture, kind of. We've got Heroku, we've got Mongo HQ, and then we've got Amazon Web Services. We do some other stuff with Amazon. We are using EC2 for some other things. We do use S3. There's another service that we make use of. This is Loggly. We have a whole web component where we built the whole thing in Rails. And that's so I didn't focus too much on those other things because those serve up, let's say, value on the website. And this is about mobile backends. So we got funded in January, and we went live in June. And so over the last 10 months, we've learned quite a few things. And I thought the two things that I would share with this crowd. And the first one is actually one that both my CEO and I really enjoy talking about because, again, the CEO, he's a geek like the rest of us. That's a compliment. And what we discovered is that devices, when it comes to precision of time, are horrible. So, you know, we gather analytics about how an app is being used. And a large part of analytics is the date, right? The time stamp of when this event happened. And so what we initially had is we relied on the underlying device to tell us. In UTC, because these devices are around the world, tell us, event happened at 7:46 on Eastern Standard Time. And we were taking that data in, and we slowly realized, after we started analyzing data in production, that we were getting dates hundreds of years in the future. Someone had an event in 2000, 60 years in the future, hundreds of years in the future. And we also found that there were devices reporting data from 1972 before devices existed. So we quickly realized that people are running their devices and not setting the time, right? Or inadvertently had set the time in the future or in the past, and then consequently then the app is reporting that incorrect time. So we came up with a custom solution that is somewhat of an NTP solution in that I said that our agent communicates bi-directionally with us. So when an app fires up, it goes out to our servers and says, what's my configuration? Am I allowed to run on this device? Oh, and by the way, another thing that we send to that device is here's the time of our local time. In UTC, I should say, it's not local time. So our servers are kind of the master in terms of time. They tell the devices it is, let's say, noon or 12 o'clock UTC. The devices get that information, and they're able to subtract out network latency, and then they ask themselves, well, what time do I think I am? And then there's an offset, and then going forward, they apply that offset to all data. This was a huge boon for us once we got this working, because now we're confident that when we receive data we have devices in all over the world, Australia, South Korea, and whatnot, that the time that we're getting is actually the true correct time. The second lesson that we learned, and I think anybody who's playing in the cloud these days has learned this lesson, you need to plan for outages. Really, you need to plan for outages. The number one bottleneck when it comes to the cloud, and something you need to be aware of, so I mentioned that we use Mongo HQ, we use Heroku, and we use AWS. It turns out that when AWS goes down, everybody goes down. So even though you may not be using AWS, you need to be aware of who your provider is using. So for example, Heroku and Mongo HQ live on AWS along with 98% of the web. So it becomes incumbent upon you, if you're going to go down this route of leveraging the cloud, is you need to start to watch the status websites. All cloud providers now have status.heroku.com, status.mongohq.com, aws.amazon.com/status. You see, I've memorized these because I check them nonstop. They have Twitter handles and whatnot. You need to be aware of that. So that's one thing. But more importantly, you have to have a risk mitigation plan. So in our case, if Heroku goes down, we can spin up our Rails instances and our Sinatra instances on additional or augmented EC2 instances in other availability zones within AWS. Now, if all of AWS goes down, then we'll have to go to Rackspace. But you have to have a plan. So we have a series of EC2 images that have snapshots of our code. So if Heroku goes down, and Heroku went down because of AWS, let's say in the Eastern zone, then we'll fire up something in the California zone, or maybe even Australia, or not Australia, excuse me, European or Asian zones should zones go down. Yes, sir.
How does it happen? How often does it happen? It's very easy.
All right. Well, AWS went. There was the Holocaust essentially. In April, was it? They went down for something like 72 hours.
What about smaller?
So AWS every once in a while will have a hiccup. We use multiple services. So we use S3, EC2, SQS. I'm probably forgetting another one that we use in there. Those could go down every once in a while. Heroku and HQ, Mongo HQ, they also go down from time to time. I would say probably once a month we have a failure somewhere. The good news is that most of the time they come right back up within the hour. And thankfully it usually happens on like Sunday mornings. Time? T-5. So they do go down. And the one thing you need to be aware of is that when they do go down, you have very little control over that, as opposed to back in the day when you were running the servers in the in the back end room, and you could blame the one guy who kicked the plug. Can't do that anymore. You just have to sit back, and I get emails and phone calls from my boss saying what's the problem? Why is our website down? And so our game plan there is if it's longer than an hour, then we have to start looking at, okay, this looks like a big problem. We'll fire up some images over here and get this thing up and running. But it is monthly. So for resources, if you're looking at, again, a very lightweight backend system, I would recommend looking at Sinatra. That's Sinatra RB. MongoDB, Mongo HQ, pretty easy to remember these URLs. Heroku, and AWS for Amazon. Last but not least, thank you very much for having me. I finished slightly early. I would definitely encourage you to, if you have questions, email me or come and talk to me afterwards. And go to our blog, app47.com/blog. I blog, everyone else blogs, and we'd love to hear from you. Thank you very much for having me.